Where was I? Yeah, the idea of the fourth dimension remained for a long time shelved, and by specialists was regarded as purely mathematical, and by non-specialists as mystical or occult. But if we start from the moment of the appearance of this idea at the beginning of the 19th century and make a brief survey of the development of scientific thought from that moment up to the present day, it may help us to understand the course which the further development of the idea may take. At the same time, we may see what this idea tells us or can tell us in regard to the fundamental problem of the form of the world. The first and essential question which arises at this point is that of the relation of the physical sciences to mathematics. From the ordinary point of view, it is taken as an admitted fact that mathematics studies the relation of quantities in the same world of things and phenomena as that studied by the physical sciences. From this follows two more propositions. First, that every mathematical proposition must have a physical equivalent, though it may still be undiscovered at the given moment. And second, that every physical phenomena can be expressed mathematically. As a matter of fact, neither of these propositions has any foundation whatsoever, and the acceptance of them as axioms arrests the progress of thought along the very lines where progress is most necessary. But this will be dealt with later. In the discussions which follow of all the physical sciences, we shall examine only physics proper, and in physics we shall have to pay most attention at first to mechanics. For since about the middle of the 18th century, mechanics is assumed, or I should say since about the middle of the middle of the 18th century, mechanics has assumed a predominant position in physics. So much so that until quite recently it was considered both possible and probable that a means would be found of interpreting all physical phenomena as mechanical phenomena, or even phenomena, because I'm not sit up. That is, as phenomena of motion, motion. Some scientists even went much further in this direction and, not content with admitting the possibility of finding a means of interpreting physical phenomena as phenomena of motion, asserted that this means had already been found, that it explained not only physical phenomena but also phenomena of life and thought. At present, one often meets with the division of physics into old and new, and in its chief lines this division may be accepted, but it should not be understood too literally. I will now make a brief survey of the fundamental ideas of old physics which led to the necessity for building new physics, which has unexpectedly destroyed old physics. And then I will come to the idea of new physics, which led to the possibility of building a new model of the universe, which destroys new physics just as new physics destroyed old physics. Old physics lasted until the discovery of the electron, but even the electron was conceived by old physics as existing in the same artificial world governed by Aristotelian and Newtonian laws, in which it studied visible phenomena. In other words, the electron was accepted as existing in the same world in which our bodies and other objects commensurable with them exist. Physics did not understand that the electron belongs to another world. Yeah, I know, because I speak to them all the time. Old physics was based on certain immovable foundations. The space and time of old physics possessed very definite properties. First of all, they could be examined and calculated separately. That is, the being of a thing in space in no way affected or touched its being in time. Further, there was one space for all that exists, and all that occurred in this space. I should have read that. It's one sentence. Anyway, time also was one for all that exists and was measured always and for everything by one scale. In other words, it was considered possible to measure with one measure all movements possible in the universe. The cornerstone of the whole understanding of the laws of the universe was the principle of Aristotle concerning the unity of laws in the universe. This principle, in its modern meaning, can be formulated in the following way. In the whole of the universe, and under all possible conditions, the laws of nature must be identical. In other words, a law which has been established at one place in the universe must hold good at any other place in the universe. On the basis of this, science, in studying phenomena on the Earth and in the solar system, assumed the existence of the same phenomena on other planets and in other solar systems. I missed out science. On the basis of this, science in studying phenomena on the Earth and in the solar system, blah, 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 blah. Anyway, this principle attributed to Aristotle, in reality, was certainly never understood by him in the sense which it had acquired in our times. The universe of Aristotle differed greatly from the universe as we conceive it. The thinking of the people of Aristotle's time differed greatly from the thinking of the people of our time. Many fundamental principles and many starting points of thought, which we can accept as firmly established, had to be proved and established by Aristotle. Aristotle endeavored to establish the unity of laws.